This is a diagram of ammeter. Now, the ammeter usually connected in series in a circuit. Okay, you are all welcome back to Scholars Universal School, the part 2 of our electric field. Now, we'll be talking about production of electric current. We have rightly defined electric current in our previous class to be charges in motion. Now, how do we produce this electric current? That is what we'll be talking about in this part of the class. Now, electric current or a continuous flow of charge can be generated from 4 different forms. It could be gotten from chemical energy, heat energy, which we call the thermoelectric effect, the kind of continuous flow of charge that is gotten from heat. Now, mechanical energy, a very good example is your generator. Now, your generator converts mechanical energy into electrical energy. Now, your solar energy also has a form of energy gotten from the sun, and we'll call this photoelectric effect. Now, the kind of charge that is gotten from solar energy. Now, for the purpose of this class, we would only talk about the electric current that is produced from chemical energy. In the course of the subject, we'll still be talking about the thermoelectric effect, mechanical energy, and the photoelectric effect. For the purpose of this class, we'll be talking about chemical energy only. Now, electricity from chemical energy. Now, electricity is produced from chemical energy through the use of what we call electric cells. A combination of these cells is what we are known to, what we are familiar with, which is what we call a battery. Now, a battery is a combination of cells, but when we have one, it's called a cell. When we have more than one, it's called a battery. Now, the form of electricity or the form of charges gotten from chemical energy. Now, a cell is a device that is used to convert chemical energy into electrical energy. Now, the cell converts chemical energy, converts a form of energy, which is chemical energy, to another form of energy, which we refer to as your electrical energy. Now, your cell consists majorly of two dissimilar metals, which are usually separated by a solution of various acids or salts. Now, the metals we make use of, the two dissimilar metals we make use of, is what we call electrode. Now, from the diagram we have here, we can see this metal, which is your copper. It is called your copper electrode, and this is your zinc electrode. Now, these are the two electrodes that you make use of in your cell. Now, your copper electrode and your zinc electrode. Now, also in your cell, you would also have a solution. Now, the solution in which the electrodes are dipped inside are what we call electrolytes. Now, for this diagram, the electrolyte here is your dilute sulfuric acid that we have in this type of cell that we have here. So the electrodes would be your copper electrode and the zinc electrode. Then the electrolyte will be your dilute sulfuric acid. Now, the positive electrode is known as the anode. The positive electrode is known as the anode, while the negative electrode is what we call the cathode. So, any one of this electrode which is made positive or negative, now for the positive it is called the anode, and for the negative electrode is called the cathode. Now, we'll be talking about different types of cells that we have. Now, majorly we have two types of cells. We have majorly two types of cells. The first one is the primary cell, and the second one will be the secondary cell. Now, let's define what the primary cell is. Now, primary cells are those from which current is produced as a result of a non-reversible chemical change. When we say a non-reversible chemical change, that's a kind of a chemical reaction that cannot be reversed. When the reaction has occurred, you cannot reverse the reaction. As a result of that, those type of cells cannot be recharged to their original condition. When you have used every of the solution and electrodes up, you cannot recharge this type of cells. So those kind of cells that cannot be recharged and in which the reaction is non-reversible are said to be primary cells. Now, for the purpose of this class, we would also majorly talk about these primary cells. In the course of the class, we'll talk about the secondary cells. Now, for the primary cells, the major examples of primary cells that we have is the simple cell, the Daniell cell, and the Leclanché cell. Now, the Leclanché cell could be either wet or dry. Okay, now, a definition of secondary cell now. We said secondary cells are cells whose chemical actions can be reversed, like I've explained earlier. Now, they are just the opposite of your primary cells. For your primary cells, the chemical reactions cannot be reversed. And once they are used, you cannot recharge them. But for the secondary cells, they are also called accumulators. Now, for the secondary cells, the chemical reactions there can be reversed. Now, in reversing the chemical reaction, you just change the direction in which current had flowed through the cell. When it is supplying current, you change the direction. Obviously, you have reversed the reaction of that cell. So reversing the reaction, the cell is charged. Now, the major advantage of this accumulator is that they can supply current for a longer period of time as compared to your primary cells. Your primary cells have a short lifespan compared to your secondary cells. So the secondary cells can supply current. They give continuous flow of current. Both the primary cell and secondary cells are meant to give continuous flow of current. But secondary cell gives continuous flow of current for a longer period of time. And they have a very low internal resistance. The secondary cells, they have very low internal resistance. Now, the examples of secondary cells will be your lead acid accumulator and your alkaline or nickel ion accumulator. In the course of the class, we'll be explaining deeply the secondary cell. Now, for the purpose of this class, we'll be talking of the primary cells majorly. Now, the first example of the primary cell we gave is the simple cell. So we'll be talking about the simple cell. Now, the structure of the simple cell is in such a way that it consists of a copper rod and a zinc plate, which is immersed in a container, which is filled with dilute sulfuric acid. You have a copper rod and a zinc plate. Now, the copper rod serves as the positive electrode, and the positive electrode is called the anode. And the zinc plate serves as the negative electrode, which is your cathode. Now, a diagram showing the simple cell shows the copper electrode and the zinc electrode immersed in a solution. We have rightly explained that the solution is called electrolyte. Now, you have your copper electrode and your zinc electrode immersed in a solution of dilute sulfuric acid, acting as the electrolyte. Now, the chemical reaction is such a way that when the electrodes, the copper rod and the zinc plate are joined by a conductor, the zinc slowly dissolves in the acid, and we'll see that bubbles of hydrogen gases are usually formed at the copper rod. Remember that the copper rod is the positive electrode, which is your anode. Now, as a result of these chemical reactions, electrons flow through the connecting wires from zinc to copper. Now, this is a diagram showing a simple cell. So when the zinc slowly dissolves in the acid, we'll see that bubbles of hydrogen are usually formed at the copper rod. And as a result of this chemical reaction, electricity would flow through the connecting wires from your zinc electrode to your copper electrode. Now, like I've rightly explained before, that simple cell usually give a supply current for a short period of time. And the reason for this is that the simple cell have some defects. They have some little defects that would not allow them to supply current for a longer period of time. Now, the first defect of the simple cell is what we call polarization. Now, the defect of polarization is due to the formation of hydrogen bubbles around the copper plate. I have actually explained that the chemical reaction that occurs is that hydrogen bubbles will be formed at the copper plate. Now, these hydrogen bubbles formed at the copper plate usually produce what we call a back EMF. It causes a back EMF which opposes the flow of current in the circuit. The back EMF opposes the flow of current in the circuit. And the second defect of the simple cell is what we call local action. Now, the local action is due to impurities in the zinc plate. Now, these impurities, either it could be iron or carbon, they will set up a tiny cells around the zinc surface and they produce bubbles of hydrogen. Now, this activity leads to the dissolution of zinc plate into the solution. As a result of this, there's a dissolution of zinc plate into the solution. So as much as you have this zinc, as much as you have the zinc plate dissolving into the solution, it also causes something we call a back EMF, reducing the amount of current the cell can actually produce. Now, these defects can actually be catered for. Now, there's a way we can reduce or prevent this defect of simple cell. Now, for your polarization, which is the first defect of the simple cell, to reduce or prevent the polarization, we make use of suitable chemicals we call depolarizers. Now, the major function of this depolarizer is to oxidize the hydrogen that has been formed in the zinc plate. It is to oxidize. Now, oxidation would mean addition of oxygen to the hydrogen you have there. So, examples of depolarizer could be manganese dioxide, potassium dichromate. They are very good examples of depolarizers. So, depolarizers are used to reduce the effect of hydrogen bubbles formed in the zinc plate. Now, local action can be prevented by a process we call amalgamation. Now, amalgamation simply means that we coat the zinc plate with mercury. The zinc plate is coated with mercury so that there would be no direct contact between the zinc plate and the electrolyte that we have in the cell. So the mercury in that zinc plate prevents impurities from coming in contact with your dilute sulfuric acid that would make use of in this simple cell. So the two major ways of reducing, the major way of reducing polarization is by using depolarizer, and for local action is by amalgamation, that is rubbing the zinc plate with mercury. Thank you for learning with us at Scholars Universal School.